Space Encyclopedia by National Geographic Kids Edition. It is a tour of our solar system and beyond. So we're just going to take a look inside. So look. So the first page we're going to read about is space weather. Our planet has its own atmosphere and its own weather, from calm to stormy. The Earth lives in the light of the sun. The sun too has weather, and its storms can affect our world. The sun is constantly giving off both radiation and the solar wind. We feel the radiation mostly as life-giving warmth. Our atmosphere blocks most of the dangerous radiation, the kind that can give us cancer if we aren't protected. Solar storms. While the sun's heat is always steady, its blast of charged particles can change from hour to hour. Active magnetic regions on the sun sometimes shoots out solar flares or clouds of magnetized gas called coronal mass ejections. These explosions of solar gases contain high energy, radiation, and charged particles. Speaking of the sun, the sun is a middle-aged star about 4.6 billion years old. As the anchor that holds our solar system together, it provides the energy necessary for life to nourish on Earth. It accounts for 99% of the matter the solar system. The rest of the planets, moons, asteroids, and comets added together amount to the remaining 1%. Also, like other stars, the sun revolves around its galaxy, located halfway out in one of the arms of our Milky Way galaxy. The sun takes 225 to 250 million years to complete one revolution around the galaxy. Here is Jupiter. Can you imagine a planet with no ground to walk on? Or a world where a red hurricane 3 times the size of Earth has been raging for centuries? What about a planet where ferocious winds rip through the skies at 400 miles per hour? Brilliant bolts of lightning blast across the sky, and auroras dance around the poles. Some people have called Jupiter a failed star. They say that if Jupiter had been just a little bit bigger when it formed, nuclear fires would have ignited deep inside it, radiating heat and light, just like our sun. If that had happened, we would have had 2 suns in our sky instead of 1. Saturn is my favorite planet. When people first see Saturn through a telescope, they usually gasp in wonder as our spaceship gets closer to the 7th planet. We can see its beauty close up. No other planet in the solar system has the visual splendor of Saturn. When Galileo pointed his own crude telescope towards it in 1610, the telescope was not good enough to separate the rings from the rest of the disk, so he thought he'd found a triple-bodied planet. Today, we know all 4 gas giant planets have rings, but Saturn's are the only ones visible by a telescope from Earth. Surrounded by a brilliant halo of ice and dust, Saturn seems to mimic the formation of the early solar system. then there's Pluto, which, contrary to popular belief, still believe is a planet. For 76 years, Pluto reigned as the 9th planet in our solar system. In 2006, everything changed. Like a popular sports star who gets dominated to second string, Pluto has been reclassified as a dwarf planet. Originally, astronomers thought Pluto might be about the size of Earth. Its true size was difficult to tell because it was so far away. No matter what telescope was used to look at it, no details could be seen. It simply appeared as a speck of light. The best the Hubble Space Telescope could do was capture an image of a small ball with patches of dark and light. We now know Pluto is smaller than our own moon. Pluto is located in the Kuiper belt, where comets that return again and again originate. Made of rock and ice, it's very comet-like in composition. If this dwarf planet could somehow be relocated near the sun, it would have a tail and look a lot like a comet. Pluto also has a large moon named Charon. Because of their sizes, Pluto and Charon together are considered a dwarf double planet by many astronomers. Over time, land masses thrust up by volcanic activity began to rise out of Earth's oceans. These land masses began to drift and collide, growing larger and larger until they formed a giant supercontinent called Rodinia. Rodinia eventually broke apart into smaller continents about 225 million years ago. The smaller continents pushed together again to form Pangaea. Slowly, after another 94 million years, the supercontinent spread into the continents we see today. Even today, the continents are drifting. Scientists predict that 250 million years from now, North America will collide with Africa, and South America will wrap around the southern tip of Africa. By then, the Pacific Ocean will cover half of Earth. The idea that the solid ground we are standing on may be slowly moving is difficult to believe. Even more amazing is that the interior structure of Earth is still pretty much a big mystery to us. Seasons in the North Hemisphere. The reason we have seasons can be confusing. Some people think summer occurs in the hemisphere closest to the sun, and that the hemisphere farthest away experiences winter. This sounds like a great explanation, but unfortunately, it's wrong. Seasons occur because Earth tilts 23.5 degrees on its axis. That tilt affects the intensity of the sunlight hitting the surface, and that in turn causes the seasons. When North America, Europe, and Northern Asia are having summer, it's because they're tilted directly towards the sun and receiving the most concentrated sunlight. During the same time, in the southern hemisphere of South America, Africa, and Australia are tilted away from the sun, so sunlight is less concentrated and there's less heat. 6 months later, when Earth has circled around to the other side of the sun, everything reverses. The northern hemisphere has winter, and the southern hemisphere has summer. In January, when people in Vermont are out skiing down snowy slopes, Australians down under are waxing their surfboards and sunbathing on the beach. What is the Milky Way? Our galaxy, the Milky Way, appears to be a band of stars in the sky, but it's actually a disk. Hundreds of billions of stars are clumped into lines called spiral arms. Because they spiral outwards, when we look up at the night sky, we're seeing the edge of the disk, like the side of a frisbee. Earth is located about halfway between the center of the Milky Way and its outer edge. In one of the spiral arms, light from the galaxy center takes 25,000 light years to reach us. Our solar system orbits the galactic center about once every 230 million years. The last last time we were on this side of the Milky Way, the earliest dinosaurs were just starting to emerge. At the galaxy center, frequent star explosions fry huge sections of space. Those explosions would wipe out any life on nearby planets. We're lucky that Earth is located where it is far away from the center. Globular clusters. The Milky Way and other large galaxies are home to a special kind of star cluster, a globular cluster. These round balls hold up to 1,000,000 stars. They are spread over a volume of several tens to about 200 light years in diameter. If you think of the sun as living in a quiet suburb, then the stars in a globular cluster are living in a crowded city center. If you were to visit a planet inside a globular cluster, the night sky would be spectacular. From Earth, we see only a few thousand stars with the unaided eye. The sky of a globular cluster planet would be filled with 100,000 stars or more. Dark matter. Seeing the light of very distant galaxies is a great achievement for astronomers, but they face an even more difficult problem: seeing the dark. Scientists have known since the 1930s that the universe has unseen matter whose gravity pulls on visible matter. No one knows, however, what this dark matter really is. Trying to solve this puzzle is one of the most important problems in modern astronomy. Astronomers did find hints of dark matter when they studied rotating spiral galaxies, including the Milky Way. Rotating galaxies are like merry-go-rounds. Their speed depends on how much weight is on them and where it is located, whether in the middle or on the edges. intelligent beings. The possibility that intelligent beings exist out there on other worlds is something humans have imagined for a long, long time. Though there may be some forms of life on Jupiter's or Saturn's moons, there's probably no other intelligent life in the solar system. To find intelligent life, we have to look elsewhere. Astronomers have discovered about 900 planets circling nearby stars. Most are giant worlds, either very hot or very cold. Scientists are pretty certain we won't find intelligent life on these worlds. However, they also believe that we will soon begin to find more small Earth-like planets. There are two theories about the source of intelligent life beyond Earth. Many scientists believe intelligent life is a natural part of evolution and is common throughout the universe. The Drake equation. More than 50 years ago, astronomer Frank Drake came up with this equation to figure out how many intelligent civilizations might exist on our galaxy. He considered the possible number of civilizations that might be capable of communicating, the fraction of stars with planets, average number of planets, and how many could support life. How many would have intelligent beings who wanted to communicate, and how long those civilizations might last. Based on his assumptions and today's knowledge, there could be a few thousand alien civilizations somewhere out there among the hundreds of billions of stars in our galaxy. Last page is exploring the universe. Human exploration will not be limited to our solar system. Now that we know that planets are common around other stars, we will have to visit them, and where better to start than with our closest neighbor, Alpha Centauri. The Alpha Centauri star system has 3 stars. The 2 brightest, Alpha Centauri A and Alpha Centauri B, circle each other closely. A third star, Alpha Centauri C, is a red dwarf and orbits farther away. In 2012, tiny wobbles in the motion of Alpha Centauri B told astronomers that an Earth-sized planet is orbiting it. The planet is too close to the Sun-like star to support life. In fact, its surface is probably molten like lava. But planets this size often have siblings, and many astronomers believe they will find other planets in more distant orbits. planet near Alpha Centauri that could conceivably support life. Extraordinary photographic image of Saturn's rings, Jupiter's moons, and stars in the cosmos. Lively essays with clear and fascinating explanations of the latest and greatest astronomical discoveries from dark matter to the surface of Mars. A tour of the 13th planet solar system. Sidebars and a timeline on the amazing discoveries in the history of astronomy. A timeline of the age of the universe and our place in it. And stargazing tips, including binocular icons that show you how and where to look for incredible space scenery. I hope you enjoyed talking about space and learning